Okay, so let's start. So when we talk about containerization, we have to think about the fact that actually it belongs to a continuous integration on a continuous delivery processes. So this afternoon, we will focus on the build phase of this flow, of this continuous flow. The build phase is, of course, belonging to the continuous integration phase, which is some steps before the delivery, the continuous delivery flow. But you have to keep in mind this total continuous flows with no discontinuity. One of the main characteristics of containerization is the fact that the application is clearly divided into two phases. First, you have the build phase, and then you have the run phase. And they are clearly separated. And the benefit of it is that you always know what is running and how it is configured. You don't have to think about installing, provisioning new machines, and provisioning VM, installing software, making updates on that, etc. You don't have to think about it anymore. You just have to focus on the configuration at the build phase, install your apps, all its dependencies, and all the binaries you need to run your app, and that's it. And you have the security to be sure that each time you run a container on top of that image, it will behave the same wherever you run it. And you know always what is running and how it is configured. That's it. So we don't need an extra OS anymore. So talking about the automation of the building of the container, first you have to create your Dockerfile, the phase we will focus this afternoon. When your Dockerfile is clearly set, you have everything, each step defined, you are ready to build your image, which is the second phase. The third phase is, as soon as your image is built, you just have to run it. What does it mean? You run it into a container. Container is just the instance of your image. And when you are happy with your app running in your container, you are ready to push it and to pass the torch to the second part of your team, which is the continuous delivery team, ready to pull it, to run it into production or into another environment. So what is a container? Simply one package, with one rule, one app, one container. And it brings you into the microservices. What a container contains? A container contains just your application, all its dependencies and binaries you need to run it, on some configuration file that you need to run it. And when you think about containerization, again, the difference you have between your image in terms of distribution, distro, etc., and underlying infra you have on your OS are totally abstracted away, which is the beauty of containerization and isolations. The main actor in this arena is clearly Docker. And despite the fact that Docker is only 4 years old, it claims to have biggest company in this arena. Think about Netflix, GE, PayPal, just to name a few, are running Docker on production at a very high level. So Docker provides several components. You have here the main one. First is the Docker daemon. The Docker client, which is able to talk each time to the Docker daemon and to manage your image. So you have a bunch of instructions at the Docker client level, allowing you to build your image, allowing you to run your container, each time talking to the daemon, and of course, storing your image in the local registry. So just a quiz. If I'm running 5 containers with its own application in each, how many OS kernels are running on my machine? And obviously, the answer is 1, which is now obvious, but not so common when you have the habit to think about VM. So again, keep in mind the only OS you have is where Docker is installed, whatever it is. If it's on a desktop or on a cloud or on a typical classic server. So first of all, when you have to start somewhere, and as always, you have to install something. So Docker provides you several distributions in several editions. So depending on the fact that you are running on desktop, cloud, or servers, you have to choose after the kind of edition you want, either the community edition or enterprise edition. Of course, the community edition is for free. As soon as you have installed Docker, you have to check if everything is OK by just running Docker version. On Docker version, we'll talk to the daemon to provide you 2 information, the client version and the server version. If you want more details on all the parameters you have set at your Docker installation, you can run the Docker info. And Docker info gives you lots of parameters. One of them, which is really important, is the storage driver. And as a start, you need to pay attention on this parameter. InterSystems support, if you are running on Linux, the device mapper storage driver, which is most often the default one. But if you are running Mac or Windows distribution with Docker, you have by default device mapper, but we don't support it on Mac, on Windows. So you have to use another union file system, AUFS. And you have to go to the advanced option to set storage driver equal AUFS. So now it's time to dive deeper into Dockerfile. What is Dockerfile? So the Dockerfile gives you the ability to define each step to build your image into just file. It's a configuration file. Again, you configure, you know what you configure in order to be sure to know what is running when you have your image built and ready to be run into a container. So again, the idea behind this is to be able to be sure that your image will behave exactly the same wherever it runs. It's powerful. The first instruction you have in a Dockerfile is a from. You never come from nothing. Actually, in Docker, you can start from scratch. But it means that you are starting from nothing. But it's not the more convenient way to start when you are building your image. After choosing not scratch, you have another option to choose regarding InterSystems area. You can either think the same way you think when you build your VM. Just start from the OS, CentOS, for instance, which is not the best way to go. Because from here, you have to download your tarball distro from Cache, Ensemble, or Iris now, and to provide the installation phase into your Docker files. It's quite easy. It's, of course, supported. But again, it's not our advice. Our advice is clearly for you to download an already built image, either from Cache, Ensemble, or Iris. So we will provide soon an official distribution of Iris, Ensemble, maybe on Cache, from where you can start. So again, the advice is starting from this area, from our official distribution. Another thing you have to think about is the from clause contains two parameters. The name, where it can be downloaded, pulled from a Docker store. And the second parameter is the label, which is a tag name. And tag name is really important because it gives you which version you are coming from. If you don't provide the tag name, you will by default get the latest. And the latest is not always the best way to control what you are installing. So to be sure to install each time the good version, for instance, global summit, which is of course not a real version, you have to precise name of the repository, colon, tag name, always. Avoid the latest. Another thing you have to think about regarding security is the environment variables you have to set in your Docker files. Environment variables are clearly useful when you have to run your instruction, but some of them are exposed. And by default, all the environment variables are exposed when you run your container. And sometimes you need to think about the fact that some environment variables are sensible, as password, for instance. So instead of using env, you have the ability to use arg with no default value, which means that you will pass these args in the line of commands of the run. Each instruction of your Docker files creates a new layer. The idea behind the image is to be the smallest image at the end in terms of disk space. So you have to think about the number of instructions you are providing in your Docker files. The fewer, the better in terms of size of the image. So when you think about the run command, you have, as a good practice, as a best practice, to just have a single run command, which means single layer, building all your Docker file. Same case as the from with the latest, avoiding the from with latest. You have to precise clearly which version you are installing on which application you are downloading or installing on top of your Docker file. So again, a good practice is to set clearly, to control clearly what you are building and to control what is running by providing each time it's necessary the exact version you want. Again, it's in the same area of regarding the size of your image, the smaller the better. You need to think about some option you have, either add or copy. You will see that in container instruction, you have sometimes quite equivalent instruction. For instance, the add and the copy, but there are some differences. For instance, if you are adding in your container a zipped file, avoid the add, because it will be unzipped during the build phase. And when it's unzipped, all the space needed during the build phase is uncontractable, so you cannot retrieve this space. So at the end, you will have a bigger image because of this unzipped phase. So instead of that, use copy. And even better, each time you use add or copy, think about the ability to put it into the run, the single run command, and to, instead of copy it, download it at the run level, at the run stage, which means, again, just one layer, because everything is one single run command. And again, you get a smaller image, which is best. At the end, you have a full Dockerfile, which is sometimes bigger, but sometimes so with so few instructions. Of course, I encourage you to go to the Docker reference, where you find all the details on every instruction. And after that, you are ready to build your image. So the building is just one instruction, Docker build, as simply as that. -t to name it, to tag it, and to give whatever name you have. Again, name, colon, version as the best option. And before that, you have to go to your directory where your Dockerfile is defined. And the period at the end of the instruction means that you want to build it locally. At the end, you have the Docker images, which allow you to see the name of your image and its size. As soon as you have built it, you are ready to run, simply by Docker run, as simple as that. Most often, you don't type the Docker client command at the shell level. Most often, you preferably use a shell script, bash or whatever, in order to repeat your command and to pass all the parameters you need. For instance, here we see that we are running Docker with the -d, which means that it will be run in background, detach mode, and we are passing several ports. We are opening and making the equivalence of the port exposed by our Dockerfile. And we can set the host name of your internal image by -h and some other options. At the end, because it's a script shell, you can, of course, add some instruction. As soon as your Docker is running, as your container, is running, you can dive into it immediately on production through the exec-ti. T for cdo tty, and I for interactive. You just have the name of the container running and set which instruction you want to execute. For instance, a bash. So if you execute interactively this kind of bash, you are able to dive again into a running container and execute whatever you want. C-control all, for instance, or ps-ef, whatever. You are happy with your application running in your container. You are ready to push it and to, again, pass the torch to the delivery team, able to pull it. But before that, you need to push it into a public repository. So most often, you have to log in to this repository, and then you have to tag your image, not your container, your image, because you are pushing, again, not a container, but an image. Think about the two separated phases, build and run. And you need to push your image. Just have to rename it. Tag is the option to do that. And then to push into your private or public repository. And then your delivery team is OK to not always pull it, but just run it. And the run will check if the image is available locally and if it needs to be pulled first. But you can do it in one command. If you just run it, it will pull it for you at the first run test. Some other options are available. You have export, import. You have save. You can save locally, which is sometimes useful when you want to avoid, when you totally remove all your Docker images. Before that, you can save it locally to tar.gz, for instance, in order to be able to load it without having any network needed. Some other options which are useful when you want to know what is inside your image in terms of history. You have the Docker history, and just set your image name. And you can see, for instance, this is the iris history. And you can see 12 months ago, there will be a maintainer on GitHub, etc., etc. You see Nick, Bobek, etc. You have the total history of the image from where you are starting your Dockerfile. And you have some other advanced options for, I'll talk about AUFS at the beginning, but you have the insecure registry, etc. You have lots of. Sometimes you need to remove all your running containers by one command. It's useful to have this kind of shortcut. RMI for image, RM just as the OS level. Pushing the queue is a quick list, the quick reference, just the name of just the tag of your image. And now it's time for a demo. So the Docker image I just have here is one image that I just pulled before this presentation, which is only the iris, the last version of iris. You have the time it has been built 2 days ago on each side. From here, I will be able to define my Dockerfile. So here using Eclipse, but you can use whatever text editor you want. It's pure text, so really simple. So from that label, that image, InterSystems iris, :GS 2017, you just have to define different arguments you want, different env variable you need. And in few commands, you will see that we will add the widget directs applications that maybe you have seen in some other sessions this week. And it is clearly simple. We just have to copy locally each files we are needed, which are just local source code. So we copy it simply at this level. Everything is copied locally. And then we are creating from scratch by simply echo command a script that we will run at the build stage to install our app. Really simple. So you can recognize some load command to load everything we have had before. And then you have the execution of util build. And even population of data. So clearly, each step of your script is written from scratch here. And at the end, we just have to C control start, iris, open a C session, running your script. That's it. Just after, you have to C control stop and remove CP some files you need, of course, some static files you need, and remove everything you don't need anymore because it's installed. At the end, you just talk about which port you are exposing, classic ports, internal ports, and web server port. On the entry point, which is a C container main, originally written in Go by Luca, but now it's written in C, just to start and stop your InterSystems iris data platform, or of course, cache ensemble. Same. The same C container main. So now I will just build it. So I have a script. Oops. I need first to go to the good stage of my demo. And I have a script which is really simple, which allow me to build the image, giving it a name, dash tag IDP version v $1, and 2 arguments, the password, in order to not expose it in the container. So I just have to build it, giving it a version name, and it will immediately execute each step of my Dockerfile. So really easy. And you will recognize everything you need, the load, the utility, compile, populate, etc. Even the fact that at the C start, you have your license will expire in 5 days. Many common situation. Okay? And now I'm ready to run it. So again, I have a script shell, drun, which allow me to run it through the Docker run, -d, detach mode, and providing the port. And you can map the port to whatever you want. By default, if you don't specify the port, Docker will take it for you. And you will be able to see it when your Docker is running. Oops. So from here, I'm ready to run it. I will just clear. And I run, my script, version 1. And I'm OK. So from here, I'm able to run, my Docker. And we see which version it is, etc. And you can see that it's not a Mac. So it's running from a Red Hat, the distribution from the image I've built, version 18.1, etc., etc. So classic. But again, I have not only running Iris, I've installed an app. So I'm able to run it and to see if I'm connect that you have the classic widget direct version of with the global summit name here, allowing you to put whatever you need. Waterproof even in palm frame. Okay? So it's running. Brilliant. From Eclipse, you have some ability to see all your containers running on all your image installed on running. And you have the ability to inspect it, which is sometimes more convenient at the script shell level. And you can see every environment variable you have on every port you are using for this container. But again, to make it clear that it's not at all the same as a VM, what about running on my laptop 10 instances of this image with no so much resource than my pure local Mac? It works. Now we have 10 containers. We have 10 containers, 10 instances of one image, each running for your isolate, in a pure isolate mode, your own container, quite easily. Just think about running 10 VM on this laptop, on your scratch. Okay? So you can, from here, run Docker stats, which will show you the CPU usage of each. And so again, running 10 Iris instances in this laptop is not thinkable in terms of virtualization of VMware, for instance. Okay, so now I just remove all my container to go to the phase 2, stage 2 of my demo. And the demo is at the phase 2, it's just adding, starting now from IDP v1, adding a new layer, for instance, web terminal. Maybe some of you are knowing this beautiful app allowing you to have InterSystems in the web of your terminal. So again, much simpler Dockerfile because we just have a run command downloading for you through the curl HTTP all the binaries on all the files you need to install it. And again, C-control start, cessation, just have to load everything you need and stop. And you have installed something else on your image from your previous image or from, of course, Iris distribution, Iris image. So I just have to go to the stage 2 and then give a name of my version, and it will download it, everything I need to install web terminal. Again, start of my session. My license will expire in 5 days. And then I'm ready to run version 2 of my container, which means that I'm still able, of course, to see my version, to see my image, a new one, which means that I don't having the extract widget waterproof at Palm Spring. Again, you know what is running each time. It's a new version from IDP v1, new instance. And from here, I'm now able to run terminal. So again, just have to cut and paste and say, yeah, I'm running web terminal, which means that I'm able to do that, and to run. Oops. And to see beautifully the InterSystems, which is really nice and something everybody dream about, typically through the web. And of course, if I modify it, saying even in Palm Spring, when I save my widget, oops, if I go back and recall my command, I will see it in web terminal. So quite cool. And then again, I will start a stage 3. Same, from IDP v2, and just to add, for instance, the web DeepC, MDX to JSON version of DeepC. So same good practice, specify the version you want to add, and same kind of download through curl, C-control start, some command to modify your password, some other options you have, and C-control stop. So again, cessation to start your script, and that's it. So easy. So again, I just have to go to my stage 3, build it, giving a name, a version name, and it will execute the curl command and install it immediately on top of my IDP v2. Or or again, whatever version you want as a from. And that's it. So really quick. And now I have an extra version, which is allowing me to run some beautiful deep sea web apps. So quite easy. And to finish, I just have to tag. So if I, from here, recall my Docker images, I will just, now I have 4 images, v1, v2, v3, each with another level of web terminal or web deep sea. And now I just have to tag IDP v3, for instance, to my repo, IDP, and I will just have to push it into Docker. And the beauty of that is that it will see if some images are already existing, depending of the image, depending of the from I am using. And as InterSystems Iris is already available at the Docker store, at the Docker Cloud repository, it will just make the link for you, showing that even big images can be pushed quite quickly, which means it's already finished. So my 2 gigs image, again, is already pushed in my public repo. Now I just have to go to AWS. So with a good password. Okay, so now I'm another Ubuntu instance. And from here, I just have one hello world image. And I just have to run cd docker. I have a run script. The run script will run Iris Global Summit version from Sylvain Guilbaud at my image that I've just pushed. So I just have to run it. No pull. Unable to find locally, it will download it from me at the first run that. And in few seconds, depending on of your bandwidth, of course, you will be able to run it on AWS. Quite easy. So we just have to wait a few seconds. In a few seconds, we will be able, during that time, I can check my Docker Cloud, my repo, 2 minutes ago. So it's clearly what I've just pushed before. And now it's coming from AWS on the Ubuntu server. So again, from Mac, I've built it from a Mac, running a Red Hat Iris version. And I will run it from an Ubuntu, the same image. Again, no issue regarding it. One OS running all your image. So check everything, extracting everything, and now, in a few seconds, I will be able Okay, so now I can run, of course, everything from here. Oop. Not localhost, of course, but Iris on AWS. And now I get this. I get the same app with its own image. And I get web terminal as well on everything I need, on even deep sea. So quite easy. So you have a total cycle of how it is powerful to play with Docker container. And now it's time to introduce Dimitri.
Hello. Hello. My name is Dimitri. I am senior software developer in InterSystems company based in Czech Republic. And also I'm working in Insight Informatics with their product Libero Library Management System. This company located in Australia. And also I'm moderator on the system InterSystems developer community. In InterSystems, we use Docker Swarm, where we install all everything what we need for our development process. We use LDAP server with LDAP admin UI for our users, for our developers, and for authentication needs in our development, in our application, developing application. OpenID server also. For this, our source we store in GitLab, which is also in Docker. And with GitLab, we, of course, use GitLab continuous integration. We use Docker Swarm because I have multiple servers, and I don't need to care about which server I can use for my particular application, for where I can start my LDAP server or GitLab. It's just by Docker Swarm done. And if one of my servers died, Docker Swarm decide where to put my application. With continuous integration in GitLab, I can build my application. Actually, I have multiple sub-projects for all of my application. I built, we have front-end, server side. We have some tools for application. It's also another OpenID server. So we use Docker inside of with GitLab continuous integration. In Docker, we build all of our parts of our application, front end, cache site, or Java application, no matter. It's very, very easy. And also GitLab CI used to deploy. When I push my code to repository, my continuous integration automatically built it and, of course, deployed to some testing environment where not developer, some testers can connect and will see what you done with in our application. In Libera, we have already some Jenkins continuous integration with unit tests. It's very big task. To build application needs at least 1 hour. But now, how it works? We have multiple slave nodes with cache instance, and build process. It's like we load code to cache, run some compile it, run some unit tests, and we should clean our cache instance after that, because we need this instance clean for next build. And it means also that, okay, it means also that we need limitation of cache instances. So I'm going to replace with Docker. In this case, I don't care about cleaning my cache instance. It just I use base image for every build. It will be clean, and I just destroy it after that. And I don't care about limitation if in number of build process at once. I just want, if I want, I can build 10 or more at the same time. So, thank you.
So you can have a look at the Datadog site, which are collecting lots of information regarding Docker adoption. So I strongly encourage you to go there. And again, think about the best practice of the continuous development phase. And of course, when you are getting to the phase of automate provisioning, you are at the top level of the scale. And you can, of course, take a closer look at Widget Direct on GitHub, which is available from now, and some other Widget Direct sessions, which are still available this week, tomorrow and this afternoon. And regarding Docker, more precisely, you still have some other session with Jeff Simmons, Mike Mulkers, Dexans, and Saurav Gupta this afternoon, tomorrow morning, and tomorrow afternoon. So I will wish to thank you, and have a good end of Global Summit.